Okay, children, this is going to be your lesson 15 instructional video for Algebra 2. Here's what we're going to be talking about, basically just polynomial operations, stuff that we're already pretty dang familiar with as far as adding, subtracting, and multiplying. So that's basically going to involve combining like terms and FOILing. The big part of this lesson, the part that's, going to be new to you, kind of. You already saw it in Algebra 1, but, it's been a year. Anyway, the part that's going to be new is going to be dividing polynomials using long division and synthetic division. And we'll get into that here in a second. So let's go ahead and just review a little bit. So how would we add and subtract polynomial functions? And here we have a few examples. So number one, we're wanting to calculate f plus g. So f plus g, that's going to be equal to x plus 1. And we'll go ahead and group in parentheses. Plus x squared minus 3x plus 7. Right? So this is f plus g. And we see pretty plainly that we don't need the parentheses because all we're doing is adding and we're not distributing anything anywhere. So we can just do x plus 1 plus x squared minus 3x plus 7. Okay, and all we're going to do from here is combine like terms, which we got pretty dang good at when we were doing the systems of equations. So let's start with the highest degree term, right? Because we always want to express polynomials in the standard form. Okay, and in case you forgot, standard form is just ax to the n plus bx to the n minus 1 plus cx to the n minus 2 plus blah, blah, blah. Okay, it just goes on and on and on forever. The point is, the highest degree term goes first, then the second, then the third, and so on and so on. Okay, so our highest degree term here is the x squared. It has nothing to combine with, so we can go ahead and write that guy down. Then we have an x and a minus 3x, so that's going to leave me with minus 2x when we combine. Combine the constants, we have a plus 8. So our final answer for f plus g would be x squared minus 2x plus 8. Let's look at another example, and now we're talking about subtraction. Okay, and this can get a little more complicated than adding, obviously, just because we have that negative sign getting thrown in there. So we're going to do h minus k, right? So that's going to be equal to negative 2x to the fourth plus 3x squared plus 9 minus, and again, I'm using parentheses to group, and it's important, especially when you are, when you're subtracting. Okay, so minus negative 5x to the fifth plus 6x squared plus 3x plus 4. Okay, and all I'm going to do now, this is why the parentheses are important, I'm just going to distribute the minus into the parentheses. Okay, and that's basically just going to change the sign of everything on that right polynomial. So negative 2x to the fourth plus 3x squared plus 9. That's going to become positive 5x to the fifth minus 6x squared minus 3x minus 4. And again, all we're doing here is combining like terms. So we're going to start with the highest degree polynomial, or the highest degree term rather. Okay, so that's going to be this 5x to the fifth. There's nothing to combine with it. 5x to the fifth. Then we're looking at our terms to the fourth, and there's only one, so I'm going to bring that guy down as well. Then we need to combine the squared terms. Okay, so plus 3x squared minus 6x squared minus 3x squared is what I'm left with. And then we are going to be looking for the x's, and there's not any. That's just minus 3x. And now the constants. So plus 9 minus 4, that leaves me with plus 5. Okay, so my answer for h minus k is going to be 5x to the fifth minus 2x to the fourth minus 3x squared minus 3x plus 5. Okay, so pretty simple. It's all about just staying organized. So now we're going to do g minus f. Okay, so we're going to say g of x minus f of x. And this one's a little easier than the last example. So go ahead and distribute the minus, drop the parentheses. So x squared plus 3x plus 7 minus x minus 1. And again, all I did was distribute the minus into the parentheses. Okay, from here, again, we're just combining like terms. X squared has nothing to combine with. Plus 3x minus x, so plus 2x, plus 7 minus 8 plus 6. Okay, so now this is where it can get a little bit ugly, and we already saw an example of this in the getting ready assignment. So now we're going to multiply, and again, this isn't really anything new. Okay, this isn't really anything new. All it is foiling and then combining like terms at the end. Okay, so we're going to do g times h. Okay, so we're going to say x squared minus 3x plus 7, all multiplied, that's g, times h, which is negative 2x to the fourth plus 3x squared plus 9. Okay, and again, all I'm really doing is foiling. Okay, so I'm basically going to distribute, and it's like foiling, it's not exactly the same, but all I'm basically going to do, I'm going to take this first term and distribute it into each and every term on the trinomial on the right. Okay, so x squared times negative 2x to the fourth, so that's going to give me negative 2x to the sixth, right? X squared times positive 3x squared, so that's going to be plus 3x to the fourth. X squared times 9, that's going to just give me positive 9x squared. Okay, so I'm done multiplying out the x squared. Now I need to distribute the negative 3x. And again, I'm just distributing it into all three of these terms on the trinomial on the right. So negative 3x times negative 2x to the fourth, so that's positive 6x to the fifth. Then times 3x squared, so that's going to be minus 9x to the third. Then I'm going to have negative 27x. So I'm done with the minus 3x. Okay, and then I'm just going to distribute the 7. So minus 14x to the fourth. And then we're going to have plus 21x squared. And then we're going to have plus 63. Okay, now I just have to, and I'm not even going to do number 5 because I'm trying to keep this video short. But now all I have to do is just go ahead and combine like terms here. Okay, so let's find our highest degree term. Well, that's going to be this negative 2x to the 6th, and there's no others, right? So it can't combine with anything. And again, I'm not going to worry about example 5. Okay, so negative 2x to the 6th. Okay, next one down would be x to the 5th, and it has no others to combine with, so we're just going to say plus 6x to the 5th. Okay, then we're looking at the terms to the 4th power, so plus 3x to the 4th minus 14x to the 4th, so that's going to leave me with minus 11x to the 4th power. Then we're looking at the squared terms, so plus 9x squared plus 21x squared plus 30x squared in total. Okay, oh, and I skipped one. So we've got this minus 9x to the third. Didn't see that guy hiding in there. So let me move this plus 30x squared over so we can keep it in standard form. And there's nothing to combine that negative 9x cubed with, so it's on its own. So that little screw up didn't hurt us too much. Okay, then the x's, there's no other x's, so just minus 27x. And only the one constant, plus 63. Okay, so these can get pretty ugly sometimes, right? It just depends. But again, staying organized, taking your time, it's going to eliminate a lot of goofy mistakes, right? So now let's move on to the newer stuff. And before we can do that, let's go ahead and motivate what it is we're doing using basic long division. Back from, elementary, right? So it used to be that we would take something, so 456 over 3, well, that's the same thing as saying 456 divided by 3. right? And there's another way to express this, to actually solve this by hand, or to simplify this by hand, rather. Okay, so this guy being divided is our dividend. Okay, the guy that we're dividing by is our divisor. Okay, so the divisor, if you remember, goes outside of our little long division box. The dividend goes inside. Okay, and if you're looking at it as a rational expression, the top number goes in the box, the bottom number outside the box. Okay, so when we divide this guy, we're looking at what would we have to multiply by 3 to get near 4 or to 4 exactly. And unfortunately, there's nothing that we multiply by 3 that's going to give us exactly 4, but we can get close by just multiplying by 1. Okay, and 3 times 1, obviously, is 3. And we're going to go ahead and subtract by 3, right? You remember how to do this. 1, bring down the 5. 3 goes into 15, or 3 times what is 15, or close to 15, and we know that that's 5. And 5 times 3 is 15, and we're going to subtract the 15. Bring down the 6. 3 goes into 6, or 3 times 2 gets us close to or is equal to 6. So 3 times 2 is 6, subtract by that, and there you have it. So 456 over 3 is simply equal to 152. That would be our answer. Okay. We also have another example, except this time it's not going to work out quite so pretty. Okay, so 247 divided by 4, or 247 over 4. Either way, we would set it up the same way. So 247 goes in the box. That's our dividend. Our divisor is 4. 4 goes into 2. Well, we can't do anything but go over the 2, right? So that means we have to put a 0 here. 4 times 0 is 0. Subtract by 0. Bring down the next number. Now, 4 goes into 24 6 times, or 4 times 6 is 24, and that's what we're going to subtract by. And we bring down the 7. 4 will only fit into a 7, or 4 times what gets us close to 7? Well, 1, right? So 4 times 1 is just 4. That's what we're going to subtract by. And we're left with, if you don't remember what this is, a remainder. Okay, and in big boy, big girl school, right, a remainder simply means that we have a mixed fraction, okay, a mixed number. So we would say that our answer, yeah, of course, it's 61 remainder 3, right? But that's what we would do like in 3rd grade, okay? We're not in 3rd grade, so we go ahead and say our answer is 61 and 3 over our divisor, okay? So our answer is actually 61.75. Okay, and we're not going to worry too much about decimals a whole lot, but this is the thing that we're looking at. Okay, and another way we can express this is that our answer was actually 61 plus 3/4, right? So our actual answer plus our remainder. Okay, so let's keep that in mind when we're learning how to do this long division with algebraic expressions now, namely polynomials. Okay, so the general idea is basically the same. Okay, so we're being asked on number 1 to calculate n divided by m. So that would be n over m. Okay, and if we write that using long division like we did before, right, n, this guy here, is what's going to go in the box. So we're going to say x to the 3rd plus 3x squared minus 10x minus 24 is being divided by x plus 4, our divisor. Okay, so this is our divisor. This is our dividend. Okay, so the idea is going to work pretty much the same. I'm going to try to color code this as best as I can. But what we're going to want to do is look at the first term, right? And we're going to have to say what number times x gives us x to the 3rd power. And it turns out that that's x squared, right? And place value is going to be important here. So if we're multiplying by x squared, we're going to put the x squared here with the other x squared. Okay? You'll see why that's important later on. It's important just to help us keep organized. I'll go ahead and just spill the beans on it. Anyway, so just like traditional long division, okay, we're going to have some subtraction. So 3 went into the 4 one time, and 3 times 1 gave us the 3. So we subtracted by that. Okay, this algorithm works exactly the same, except we're going to distribute the x squared into both of these terms, x and 4. So x squared times x, that gives me x to the third. X squared times 4, that gives me positive 4x squared. Okay, now we're going to subtract. Okay, and this is important. This goes back to when we were subtracting polynomials earlier. So we can't just subtract each one. We have to distribute this minus into both of these terms. So let's go ahead and do that. So that becomes negative x to the third minus 4x squared. Okay, and we don't need this anymore, so I'm just going to mark it out. And when you get better at this, you can kind of skip this step. You'll be able to do this part in your head. So now we can go ahead and start combining down. So we're going to start on the right. So 3x squared minus 4x squared. Well, that leaves me with negative x squared. X cubed minus x cubed. That leaves me with 0. Then we just bring down the next number. So I'm going to switch colors here. Okay, so negative 10x is what we're going to bring down. So now we're looking again. We just start over. We're looking at the x and the negative x squared. We're looking at just the first terms. Okay, so x times what gives me negative x squared? Well, that would be negative x, right? Okay, so then we're going to distribute back in to the x and to the 4. So we're going to say negative x times x, that gives me negative x squared. Negative x times 4, that gives me negative 4x. Okay, and remember, we still have to distribute this minus. Okay, so that's going to become positive x squared, positive 4x. Then we combine down. We don't need this guy anymore. Okay, so that's going to leave me with negative 6x, negative x squared, positive x squared. That leaves me with 0. And we bring down the next number. Let's see, what color do I use next? I'll use blue. Why not? So, minus 24, almost done here. And we're going to rinse and repeat. Okay, so we're looking at the first number for both terms. Okay, so what times x gives me negative 6x? Well, the answer there obviously is negative 6. And we're going to redistribute the negative 6. So we're going to have negative 6x and negative 24. And then we subtract. So this becomes positive 6x. And this becomes positive 24. Which works out nicely, which means we don't have a remainder, if you see now. So negative 24 plus 24, 0. And negative 6x plus 6x, 0. Okay, so our answer for n divided by m, or if we write it another way, if we say, x cubed plus 3x squared minus 10x minus 24, all of that divided by x plus 4, well, that equals simply x squared minus x minus 6. That would be our answer. Okay, we can simplify rational, big, ugly rational expressions like this. We can simplify them using long division this way, right? That's a lot easier to do than factoring. So let's look at another example. And again, I'm trying to keep this video short. Let me look and see here what would be the best example to show you next to try and save time so it's not so redundant. Okay. I think well, either one of these. Okay, I think our second example is the best one to show. Okay, so let's go ahead and do example 2, and then we'll move into synthetic division. So example 2 is asking us to calculate P over Q, right? So that's simply 4x, so here's P, here's Q. So that's 4x to the 5th. And I'm going to go ahead and rewrite P of x in standard form, because as of right now, it is not in standard form. Okay, so 4x to the 5th minus x to the 4th plus 20x minus 8, all being divided by 4x minus 1. Okay, so let me go ahead and rewrite this guy so we can use long division on it. Okay, and this is important. Okay, we need to maintain place value, right? So you'll notice we're missing something to the 3rd power, to the 2nd power, and then we skip over and we have 20x to the 1st power. Okay, that's no bueno. So when we write this out, we need to make sure that we account for that. Okay, you'll see what I mean here in a second. So top number is going to go in the box. So 4x to the 5th minus x to the 4th. That is important. So there is no x to the 3rd, so we're going to say plus 0x to the 3rd. Okay, that's important again for place value. There's no x squared, so we're going to say 0x squared. And there is a 20x, and there's a constant. Okay, so now I'm going to go ahead and write my divisor out here, 4x minus 1. Okay, and I'm not going to worry too much about the color coding this time. Okay, because that's going to make this example take forever. But again, we're looking at the first numbers, right? So 4x times what gives me the 4x to the 5th? Well, 4x times x to the 4th, right? So that's positive x to the 4th. Okay, then we distribute back inside. That's going to give me, so 4x to the 5th minus x to the 4th. And we're going to distribute this minus into here. So negative 4x to the 5th and plus x to the 4th. Okay, so positive 4x to the 5th, negative 4x to the 5th, that's a 0. This right here is going to be a 0. And we bring down the next term. And 4x minus 1 times what, or again, we're just looking at the first term. So 4x times what will give us 0. Well, the answer there is just 0. So then we're going to bring down the next number. And again, 4x times what gives me 0? Well, 0. Okay, so then we're going to bring down the next number. And we're looking at 20x. And we need to make this a binomial, so I'm going to go ahead and bring down the minus 8. Okay, we need to have two terms that way. Okay, so 4x minus 1, or rather just the 4x is all we're worried about. So the 4x will go into the 20x how many times? Or 4x times what gives me 20x? Well, that would just be plus 5. So here we're going to have a plus 0, and then we're going to have a plus 5. Okay, so 5 times 4x, that gives me 20x. And 5 times negative 1, that gives me negative 5. And we need to distribute the minus, so this becomes negative 20x plus 5. We can go ahead and scratch that out. Okay, so 20x minus 20x, that's 0, minus 8 plus 5, negative 3. So we have a remainder this time. Okay, so what we see is this guy is equal to x to the 4th plus 5 plus our remainder, just like how we did over here. So this was our remainder, was the 3/4, right? So we can say it's our whole number plus the remainder. Okay, so that's exactly what we're going to do here. So x to the 4th plus 5 plus, and in this case, it's going to go ahead and be a minus because we're saying minus 3, right? But we're going to say minus 3 over 4x minus 1. And this would be our answer to this guy. Okay, so we have our whole answer plus our remainder. Okay, And I'll tell you what, who cares if this video is long? You know, you guys can just skip around. We'll do a third example, because this is really, really ugly the first time you're seeing it. It seems daunting, but it's really not that bad. Okay, so example 3, t over r. Okay, so that's going to be written as x to the third, so here's t, x to the third minus 7x squared plus 14, all divided by x minus 5. Okay, so let's go ahead and write that out. So that's going to be x to the third minus 7x squared plus 0x to the first power, right? We have to account for that place value, and plus our constant 14. Okay, so x minus 5 is what we're dividing by, or is our divisor. Okay, so now let's go ahead and start dividing. So x times what gives me x to the third? Well, that would just be x squared. Okay, distribute that back in. X to the third minus 5x squared. Okay, subtract, so we need to distribute the minus, so negative x to the third plus 5x squared. Scratch that out, combine everything down, negative 2x squared, and x cubed minus x cubed, that's 0. Bring down our next term. Okay, so x times what gives me the negative 2x squared? Well, that would be minus 2x. Distribute back in, so negative 2x squared and positive 10x. Oops. Yeah, you got to show every single step because I don't want to confuse you guys. So I got to distribute the minus, so 2x squared becomes positive and 10x becomes negative. Scratch that guy out. Okay, so combine down, so negative 2x squared, positive 2x squared, that's 0, plus 0x minus 10x, negative 10x, and we bring down the last number, plus 14. So x times what will give me negative 10x? The answer there is just minus 10. Start distributing back inside, so negative 10x. And positive 50. Almost did it again. Now we got to distribute the minus. So positive 10x minus 50. Scratch this guy out. And brain fart, 50 minus 14. What's that going to give me? 36. So negative 36 minus 10x plus 10x. So I have a remainder of negative 36. So my answer here to this rational expression is going to be x squared minus 2x minus 10 minus 36 over x minus 5. Right, so here we're going to learn a different way of doing long division that's a little bit it's a lot more streamlined and it's a lot quicker. The only problem, we can only use it in certain instances, right? So our traditional long division back here that we were doing, we can use that in any instance where we're dividing two polynomials, but we can't use synthetic division, but in certain instances. So let's go ahead and talk about that. So our actual EQ deals with when we can use it. Okay, so we're going to use synthetic division to calculate A over B. Okay, so A over B, well, that's going to be equal to x to the fourth minus 13x squared plus 32, all divided by, so our B, right, x minus 3. Okay, so if we're going to use synthetic division, okay, we need to have our dividend, so this guy on the bottom is our that's our divisor. We need to have our divisor be in a very particular form, namely x minus k. All right, So right now, our divisor is in that form, x minus k, and k in this case is equal to 3. So we're going to take that k term and put it here, and we're going to just put a bar right here. And then what we're going to do, so I'm going to rewrite a of x, so our dividend, I'm going to rewrite it on top here, so above the bar, so x to the fourth. And I want to account for all place values, so that includes my missing third degree, so I'm going to put plus 0x to the third minus 13x squared, and then we're missing the x to the first power, so plus 0x plus 32, right? And what I want to do now is I want to write down the coefficients for each of these terms. So x to the fourth coefficient is 1, 0. Negative 13, 0, 32. Okay, then I'm going to write a little bar down here like this. Okay, and your first coefficient, you're always just going to bring it down here. Okay, and then what you're going to do, you're going to take your k and multiply it by that first term. So 3 times 1 gives me 3. And then what you're going to do, you're going to combine down in this next column that we're in here. So 0 combines with 3 to give me 3. Then I'm going to multiply again, 3 times 3. That's going to give me 9. Then I'm going to combine down again. Negative 13 and 9 combines to minus 4. Then I'm going to multiply again. And you can see there's a pattern, right? So minus 12. Combine down, we get negative 12. 3 times negative 12. Negative 36. Combine down, we get minus 4. Right? Should kind of remind you a little bit of elimination when we were solving systems. Okay, so this is a streamlined way of doing long division, and it only works when we've got our divisor in the form x minus k. Anyway, I'm getting ahead of myself. So what we're going to do next is just go ahead and write out what our actual answer is. Okay, so this is a fourth degree polynomial, so we just divided it. Right? We just divided it by something that was a first degree polynomial here, x to the first power. Okay, so that means this x to the fourth, the highest degree we're going to have is third power. So this is going to be 1x to the third, or just x to the third. And then we're going to follow in suit with all the other terms going left to right. So we're going to say plus 3x squared minus 4x minus 12. This last column here, if there's not a 0 here in the last column, this is our remainder. Okay, so minus 4 over our divisor, which was x minus 3. Okay, so our answer here would simply be that x to the fourth minus 13x squared plus 32, all divided by x minus 3, is equal to x to the third plus 3x squared minus 4x minus 12 minus our remainder, 4 over x minus 3. Okay, so let's look at 2 more examples. That way we can really get this down. And I can't stress enough, you can only do this in the instance that your divisor is in the form x minus k. Okay, I can't stress that enough. You can't do it. So back over here, if we're dividing, let's say this was our divisor, right? 4x minus 1. This is not in the form x minus k. So we can't use synthetic division. We would have to use regular long division, right? Okay, so use synthetic division to calculate c over d. So c over d. So that's going to be x to the third plus 3x squared minus 10x minus 24, all being divided by x plus 4. And at first glance, this x plus 4, well, is it in the form x minus k? It actually is. We can rewrite x plus 4 as x minus negative 4. So now we have k equals negative 4, right? X minus k. Okay, so negative 4 is our k term. I'm going to put my little bar, and I'm going to go ahead and write my coefficients. So I've got 1 and 3 and negative 10 and negative 24. Okay? Bring down my first guy, negative 4 times 1, negative 4. Combine down, negative 1, negative 4 times negative 1, positive 4. Combine down, negative 6, negative 4 times negative 6, positive 24. Combine down, we get 0. Yay, no remainder. Okay, so again, we need to revisit. So our highest degree term, right, was our x to the third. So that means this 1 right here is going to be the coefficient of something to the second degree. So I'm going to have x squared, right? I have to do minus 1. So I'm going to have x squared minus x minus 6, and then we have no remainder. So that's just our answer. Okay, so all this nonsense, when we divide it by x plus 4, it's just going to give me an answer, or a quotient, of x squared minus x minus 6. Okay, let's do another one. And this one's going to be a little uglier. And again, when we're doing these, we have to make sure we're always accounting for place value, okay, because that will screw you up. So E over F. So that's going to be E being divided by F. So we have negative 5x to the 5th minus 2x to the 4th plus 32x squared minus 48x plus 32. All of that over x minus 2. Okay, so the x minus 2, that's in the form x minus k, so that means we can use synthetic division. And k is equal to positive 2. Okay, so we're going to say 2 and our bar, then we start writing our coefficients. Now you'll notice we went 5, 4, we're missing a 3, so we're going to have to use a 0 placeholder there to keep our place value in check. Okay, so start with negative 5, then negative 2, then 0, right, because we don't have x to the third, then 32, and then minus 48, and then positive 32. Okay, so bring our first guy down, so minus 5, then we're going to multiply 2, negative 5, negative 10, combine down, we get negative 24, combine down again, and we just keep on chugging along here, minus 16, multiply, we get minus 32, and we get minus 80, and we get minus 160, which is going to give me 128, so minus 128. So we have a whole bunch of negatives here. And our highest degree term, if we recall, is a 5th degree, so that means this 5 is the coefficient of a 4th degree term. And we're just going to go in descending order all the way down, so minus 12x cubed, minus 24x squared, minus 16x, minus 80, and then of course our remainder of 128, well, negative 128, over our divisor, x minus 2. Okay, so all of this, so the negative 5x squared, blah, 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 e of x divided by f of x, right, gives us a quotient of negative 5x to the 4th minus 12x cubed minus 24x squared, blah, 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 blah. Okay, so synthetic division is a lot simpler and quicker for when we have a divisor in the form x minus k. And again, I can't stress enough, okay, when can we use synthetic polynomial division? Only when we have it in the form, the divisor in the form x minus k, all right? So that's all we got for this lesson, kiddos. Obviously, let us know if you have any questions, and we will see you later. Goodbye.